The next question before us is the differential equation of the family of unit circles centered on the line y is equal to x is the differential equation of the family of unit circles centered on the line y is equal to x is. It's beautiful. We are given a lot of pieces of information. The first piece of information is they are all unit circles. It does mean that the radius of the circles is 1. We feel happy. So in the previous problem, r square is 1 square. One more thing, they are centered on the line y is equal to x. What does it mean? The x coordinate and the y coordinate of the center of the required circle are same. Therefore, radius, what is the radius? 1. Center. In center, both x coordinate and y coordinate are same. Therefore, I would like to suppose this to be some AA. Therefore, equation of the circle is equation of the family of circles is x minus a whole square plus y minus a whole square is equal to 1. X minus a whole square plus y minus a whole square is equal to 1. How many arbitrary constants are here? Just one arbitrary constant. What is that? A is to be eliminated. Therefore, only one constant is there to be eliminated. Hence, order of that differential equation which you are going to produce is 1. That is, order of the differential equation whose solution is the given equation is 1. Hence, just once, one and only once we are supposed to differentiate it. Okay, let us see what is going to happen. X square plus y square minus 2ax minus 2ay plus 2a square minus 1 is equal to 0. X square minus 2ax plus a square, y square minus 2ay plus a square, etc. I could have expanded this. Okay, that is x square plus y square minus 2a into x plus y plus 2a square minus 1 is equal to 0. This is the equation of the given family of circles. We have not yet produced the differential equation. We are now to do it. How many times you can differentiate? One and only once. Differentiate it with respect to x. 2x plus 2y minus 2y y1 minus 2x plus 2y y1 minus 2a into 1 plus y1 is equal to 0. Okay, from this we have 2a is equal to 2x plus 2y y1 by 1 plus y1. Of course, that is the weapon with us to eliminate a from this given equation. The only thing remained here is to place that value in the place of a. That is only remained. Okay, or a is equal to x plus y y1 by 1 plus y1. Now, you go through the steps. I would like to remove this to observe the simplified format. of the given equation. What shape that is take? X square plus y square minus 2x plus 2y y1 by 1 plus y1 into x plus y plus 2a square, that is x plus y y1 by 1 plus y1 whole square minus 1 is equal to 0. Well done. To have its simplified form, let us multiply this with 1 plus y1 whole square. X square plus y square into 1 plus y1 whole square minus, if you get 2 out, 2 into x plus y1 into x plus y into 1 plus y1 plus 2 into x plus y1 whole square minus of 1 plus y1 square. 1 plus y1 whole square is equal to 0. That is the given answer. Of course, we can expand this product and get a simplified form still. The main thing is what is the order and what is the degree of this differential equation. At most you have y1 square only. That's all, not more than that. From the first point to the last point, you can at most have y1 square, not more than that in the exponential part of y1. So it is a first order and second degree. First order and second degree. This is the equation of the system. That's it. It's a good problem. The next problem before us is, it is visible on the board. It's a family of curves whose equation is root of 1 minus x square plus square root of 1 minus y square is equal to m into x minus y. Here m is the parameter. And the only constant that is supposed to be eliminated is m only. So what is the order of the differential equation which we are going to produce? What is the order of the differential equation whose solution is the given equation? 1. Because there is only one arbitrary constant. See, direct differentiation may not give us flexible results. We do one thing, look here, as root of 1 minus x square and root of 1 minus y square are present, let me take, put x is equal to sine alpha and y is equal to sine beta. Then, how does that equation 1 change? Square root of 1 minus sine square alpha plus square root of 1 minus sine square beta is equal to m into sine alpha minus sine beta. It is nothing but cos alpha plus cos beta is equal to m into sine alpha minus sine beta. What is cos c plus cos d? 2 cos c plus d by 2 cos c minus b by 2 m into 2 cos alpha plus beta by 2 sine alpha minus beta by 2. So that you have cot of alpha minus beta by 2 is equal to m, isn't it? So that alpha minus beta by 2 is equal to cot inverse m. That is, alpha minus beta is equal to 2 cot inverse m. Alpha is nothing but sine inverse x, sine inverse y. M is a constant, cot inverse m is a constant, 2 cot inverse m is a constant. You see, this type of substitution is subjected to the domain of alpha, beta, x and y. Okay, right? Differentiate the last step with respect to x on both sides. What happens? 1 by square root of 1 minus x square, 1 by square root of 1 minus y square into y1 is equal to 0. From this, y1 by root of 1 minus y square is equal to 1 by root of 1 minus x square, or root 1 minus x square into y1 is equal to root 1 minus y square. Okay, no doubt this is the differential equation whose solution is the given equation. Look here, what is the order of this differential equation? 1, because first order, y1, first order derivative is only present. Well, my dear, what do you like to say about the degree of this differential equation? Well, here is some radical power is there, root of 1 minus x square. If you square it, then only you will have these two terms free from radicals. If you square it, then y1 square will be obtained. Then you might be in a position to say that the degree of that equation is 2. It is wrong. Why? Because for x and y are the independent variable or dependent variable, for such expressions, even though radical exponents are present, we just do not bother about it. We just do not bother about it. If at all there is any radical power to y1 or y2, then only you are supposed to remove them. So this equation is surely of first order and first degree only. That's all. You need not square it at all on both sides. If you can square it, it is as you wish, as you like, that's all. According to your happiness, you will be doing that. But we don't want that. That is the differential equation. To have the degree of the differential equation, it is 1, first order and first degree. Yes, this is about the problem. What is the differential equation whose solution is this? E power 2y plus 2ax e power y plus a square is equal to 0. That is the new problem for us on the board. Please follow it carefully. A lies at two different places. One is here and another is here. There is only one constant. So at most you can differentiate only once. That is order of that differential equation which we are producing must be 1. That is the degree of the differential equation whose solution is the given equation must be 1. If you simply differentiate it with respect to x directly, you may not be in a position to have a flexible result. Therefore, we shall do something. Look here, you follow this carefully. E power 2y plus 2ax e power y plus a square x square minus a square x square plus a square is equal to 0. I think you might have observed what is done by me. I have added and subtracted a square x square. What is the reason for that? You can write this as e power y plus ax whole square. Can you believe it? E power 2y, a square x square, 2ax e power y. Isn't it? Is equal to plus a square minus a square x square is equal to 0. This is equal to a square into x square minus 1. I think I can write like it. Okay. From this, what can you have? E power y plus ax is equal to plus or minus a root x square minus 1. Am I right? Therefore, e power y is equal to minus ax plus or minus a root x square minus 1, right? This is equal to minus a into x plus or minus root of x square minus 1, correct? Okay, let us now at this position differentiate this step on both sides with respect to x. Let us see what happens. What is the derivative of e power y? E power y into y1. So, but the derivative of e power y is e power y into y1 is equal to minus a into, come on, for x it is 1 plus or minus root x 1 by 2 root x square minus 1. For x square minus 1 it is 2x. 2 and 2 will go away. So that we have e power y into y1 is equal to minus a into x plus or minus root of x square minus 1. Minus a into x plus or minus root of x square by root of x square minus 1 is there, we have forgotten. This is equal to minus plus e power y by root of x square minus 1. This is the given differential equation. E power y into y1 is equal to. That is the differential equation. The next question is xy is equal to a into e power x plus b into e power minus x plus x square. And in brackets we were given two constants, arbitrary constants, namely a and b. We are supposed to eliminate those two. So order of the differential equation which are going to produce, that is whose solution is the given equation, must be 2 only, because there are only two arbitrary constants. Okay, before beginning the process of differentiation, let us do a very simple thing. Xy minus x square is equal to a e power x plus b e power minus x. Call this 1. Now you differentiate it. U into u derivative into v plus v derivative into u minus 2x is equal to a e power x minus b e power minus x. Again differentiate it. What y it is y1. y2 into x plus 1 into y1 minus 2 is equal to a into e power x plus b into e power minus x. Totally y1 plus y1, 2y1 plus xy2 minus 2 is equal to, what is a e power x plus b e power minus x? Xy minus x square by 1. By 1. You bring all the things to one side. What happens? xy2 plus 2y1 minus xy plus x square minus 2 is equal to 0 is the differential equation. What is the order and what is the degree of the differential equation? This is of second order. Why? Because y2 is present. That is, moreover, in the beginning of the problem itself, we could have noticed that the differential equation must be of order 2. Why? Because there are two constants to be eliminated. Okay, then degree of the differential equation is 1, because we are not able to observe any y2 square or y2 cube or any other thing. We are having just y2. So degree is 1, second order and first degree. That's it. The next problem before us is, it is visible clearly on the board. A plus bx into e power y by x is equal to x. We are supposed to eliminate the two constants a and b. Again, the order of the answer, that is the differential equation, is 2. Why? Because two constants are to be eliminated. As usual. Well done. Look here. You see, x e power minus y by x is equal to a plus bx. Any problem to anybody? I've sent this to that side. That's all. Okay. Now you differentiate it. Differentiating with respect to x, u derivative into v plus v derivative e power minus y by x into minus of, come on, derivative of y by x, u derivative into v minus v derivative into u by v square is equal to, for a it is 0, the rest of the thing it is b. So totally e power minus y by x into 1 minus xy1 minus y by x square is equal to b. I have brought e power minus y by x out, 1 minus xy1 minus y by x square. E power minus y by x into 1 minus xy1 by x square is y1 by x plus y by x square is equal to b. Now one of the happiest things is if you can differentiate this step again with respect to x on both sides, b will be eliminated. B will be eliminated automatically. It will be disappeared, of course. As so, the only step we require is the derivative on both sides. We have to differentiate this step with respect to x on both sides so that b will disappear and the so-called answer will be at our disposal. Let us do that. U dash, that is e power minus y by x into d by dx of minus y by x into 1 minus y1 by x plus y by x square plus d by dx of 1 minus y1 by x plus y by x square into e power minus y by x is equal to 0. Is equal to 0. The only bulkier process remains here. Of course, e power minus y by x you can cancel on both the sides, nothing happens. You just cancel it. Divide x of this into this product, that gives you the answer. You are supposed to simplify that. That's all. At last we could have an equation free from a and b, isn't it? Therefore, the simplified part of this one gives you the answer. That is the question. Let us see the question. There is a lot of information given and you are supposed to make use of the information in a planned way. Unless or otherwise you cannot get the requirement, that is the value of f of x minus g of x at x is equal to 3 by 2. You must use it very carefully, very, very careful. Okay, what is the data? You observed carefully. F of x and g of x are two functions. They are differentiable on closed interval 0 to 2. The first piece of information is f dash x is equal to g dash x. Second piece of information, f dash 1 is 2 and g dash 1 is 4. The third piece of information, f of 2 is equal to 3 and g of 2 is equal to 9, and we require the value of f of x minus g of x. Yes, we have got the point. On what aspect should you make the first attack? On f of x minus g of x. Okay, right. Let h of x is equal to f of x minus g of x. Implies h double dash x is equal to f double dash x minus g double dash x. See, as f and g are differentiable, f minus g is also differentiable twice also by the algebra of derivatives in the differentiation chapter. Okay then, but you see, f dash x minus g dash x is given to be 0, you know, it is 0. Implies h double dash x is equal to 0. Implies you integrate it on both the sides, h dash x is equal to a. H dash x is equal to A. But what is H dash x? Is nothing but f dash x minus g dash x is A. Is A. Okay, f dash x minus g dash x is A. But you see, I'd like to take 1 in the place of x. What happens? Implies f dash to 1 minus g dash to 1 is A at x is equal to 1. Why should you use that one only? Because it is given. We are supposed to make use of it, isn't it? Okay, what is f dash 1? 2. What is g dash 1? 4. 2 minus 4 is equal to A, isn't it? F dash 1 is 2 and g dash 1 is 4. It is 2 minus 4. 2 minus 4 is A. So what do you have? Therefore, A is equal to minus 2. Implies h dash x is equal to minus 2. Again integrate it on both the sides. What happens? H of x is equal to minus 2x plus b. B is the constant of integration. I say again h of x. I like to take 2 in the place of x. What is h of x actually? Implies f of x minus g of x is equal to minus 2x plus b. It is nothing but the definition of h of x, isn't it? Now, I like to take 2 in the place of x. What happens? Implies f of 2 minus g of 2 is equal to minus 4 plus b at x is equal to 2. What is f of 2? 3. What is g of 2? 9. 3 minus 9 is minus 6. Minus 6 plus 4 is minus 2. So b is minus 2. B is minus 2. So we have directly b as minus 2. Hence, b is minus 2. Send this minus 2 to that side. What happens? F of x minus g of x is equal to minus 2x minus 2. Minus 2x minus 2. And we require f of 3 by 2, isn't it? F of x minus g of x at x is equal to 3 by 2. Isn't it? And look here. Therefore, f of x minus g of x is equal to minus 2x minus 2. But we want 3 by 2. F of 3 by 2 minus g of 3 by 2 is equal to minus 2 into 3 by 2 minus 2. Minus 3 minus 2 is minus 5. That is the required answer. That is the required answer. Follow it carefully. Look at the question. F dash x is equal to 6 into x minus 1 and the graph of f of x passes through the point 2, 1. Also, the slope of the tangent at this point is 3. Then what is f of x? He is asking us. Let us see. Look here. F dash x is equal to 6 into x minus 1. Integrate on both the sides. F dash x is equal to 6 into x minus 1 whole square by 2 plus c. That is equal to 3 into x minus 1 whole square plus c. F dash x is equal to. Well done. Slope of the tangent at that point is 3. What does it mean? At f dash x at the point 2, 1 is nothing but f dash 2, isn't it? So f dash 2 must be 3. Slope of the tangent, what does it mean? Slope of the tangent means derivative at the point 2, 1. That is derivative at x is equal to 2. Isn't it? But f dash 2 is equal to 3. Implies 3 into 2 minus 1 whole square plus c is equal to 3. What is 2 minus 1? 1. 1 square is 1. 3 ones are 3. 3 and 3 go away, leaving you c is equal to how much? 0. Okay, C is 0. We could have got it. Therefore, f dash x is equal to 3 into x minus 1 whole square. That's all. Again, if integrate it on both the sides, what do you have? F of x is equal to x minus 1 whole cube. That is, what is the derivative of x minus 1 whole cube? 3 into x minus 1 whole square. So, integral of 3 into x minus 1 whole square is x minus 1 whole cube, isn't it? Plus k. Plus k. Well, my dear, you search in the data. Is there any piece of information which is still to be used? You look for that. Graph of the function passes through 2, 1. What is the exact meaning of that? F of 2 is 1. But f of 2 is 1 implies 2 minus 1 whole cube plus k is 1. What is 2 minus 1 whole cube? 1 cube is 1. 1 and 1 go away, leaving you k is equal to 0. Therefore, f of x is equal to, what is f of x? Just x minus 1 whole cube. Just x minus 1 whole cube. You look at that, how simple it is to estimate. Of course, it is very essential to go through every inch of the data. You are supposed to make use of that.